once again, in this lesson we're going to be still looking at expressions and tables, but this time we're going to be looking at expressions that have more than one operation, specifically multiplication and addition. So let's look at the context of this problem. The Italian Villa restaurant has square tables that the server can push together to accommodate the customers. Only one chair fits along the side of the square tables. So we want to make a model to determine this, and they've kind of started the model here for us. So let's look at the beginning of this, but I do encourage you to pause the video at this point and start looking at the pattern and see if you can come up with it on your own. So go ahead, give it a pause for a second. Good, assuming you paused already. Alright, so one table, we could fit 4 chairs. Now when we push 2 together, don't assume that there's going to be room for 8 chairs. Let's look at it. 1, 2, 3, 4, 5, 6. 6 tables. We've lost some chairs in the middle. Okay, so we can add these to our table. 4 for the first, 6 for the second. And now you can kind of notice that we're going to be continually adding 2 every time. So you look at the 3, there's 3 up top, 3 on the bottom, that's 6, and 2 on the ends. That's 8, 10, 12, ooh, 50. How can we think about this? This is going to be a little bit more tricky. So if we're looking from here to here, we can't multiply by 4. That's not going to work. It works for the first, but not for the second. We can't add 3. That works for the first, but not for the second. We need a rule that's going to work all the time. So look at this. You kind of see the ends here are kind of always there. We only have 2 seats on the ends. It's the number of seats on top and bottom that's changing. So when there was 5 tables, there's 5 seats on top and bottom. Make sense? If there's 4 tables, 4 seats on top and bottom. So if we want to kind of extend this to 50 tables, well, we can kind of draw a little mock-up of this. If we imagine 50 tables together, there's going to be 50 over on the one side and 50 on the other side, and then 1 on the 2 ends. So that's 102 tables, 102 chairs altogether. 200 would work similarly. There'd be 200 on top, 200 on the bottom for 402 total. So this repeated multiplication of 2 and adding 2 is happening every time. We have as many chairs as there are, once on top, once on bottom. That's multiplied by 2, and then we add 2. So multiply and add both happen in this kind of expression. Okay, let's look at another example. Here we're looking at pizzas. The Pizza Queen has a special offer on lunch where it's $4 for each pizza and then $2 delivery charge. Now, every single pizza costs $4, and that charge is charged every time, but the $2 delivery charge is only charged once. So if we think about this, $4 each, that's happening over and over and over. The $2 is happening once. Well, if we think about something that's not changing, that's happening once, that kind of reminds me of something we talked about at the beginning of this unit. One-time things that don't change, those are constants. So this $2 is going to be a constant amount in our expression. On the other hand, the $4, it's changing. Every time the number of pizzas, our variable, increases, this is going to increase. So this is really our coefficient. This is affecting the variable. So if P is the pizzas, 4P is really going to be how many dollars we're going to spend on the pizzas. So 4 times 1 plus our $2 charge is 6. 4 times 2 plus our $2 charge is 10. Now notice we do have now a vertical pattern here of adding 4. And that's going to continue. So we are going to have 14, 18, but wait, we jumped. Now we have 10 pizzas. So let's go back to our rule. Times 10 for the $4, and then add our $2, 42, 50. 4 times 50 plus 2 is 202. Now, see how the number in the parentheses is changing every time? That looks like a variable to me. So 4 times P plus 2 is our rule. We are multiplying and adding in this expression for this table. So we can use this to figure out for our class specifically. Our class has 26 students, and so if we take 4 times our 26, add 2 more dollars for the delivery charge, we have 104 plus 2, or $106 total for the pizzas for our class. Now, if the Booster Club had $400 to spend on pizza, we can work backwards to figure out how many pizzas they could order. The first thing we really need to think about is, let's take away that delivery charge. So take away the $2, there's $398 that we're spending on the pizzas themselves. Now, each pizza costs $4, so we divide by 4. So that would give us 99.5 pizzas. We can't order half a pizza. So in terms of real context, we can only order 99 pizzas. Okay, let's consider what happens if they change it now. $5 for pizza. Maybe we're getting toppings. And maybe it's a $3 charge as well. So 5 for the first pizza plus 3 is 8 for one pizza, then 13, 18, 23, 28. What are we doing every time? 5 times the number of pizzas plus $3 for the delivery charge. That is our rule, multiplication and addition happening at the same time.